So let me greet you with the word welcome and give you the preview of this video. Basically, this video is featuring an assessment of computer-oriented numerical methods where we were supposed to solve the internal question papers of the designated subject. So here we are featuring the solution for the third internal paper, whose first question was to derive Simpson's 3 by 8 rule using the Newton-Cotes formula. So as you can see here, the Newton-Cotes formula is NH, summation of I is equal to 0 to n, yi Cin, and Cin is defined as 1 by n, integral of 0 to n, Liu du, where Liu du is found out using the Lagrange's interpolation method. Here, we substitute the value of n as 2 in our equation number 1 to derive the Simpson's one-third rule. We get equation like this: 2h into y0 c02 plus y1 c12 plus y2 c22, and name the equation as equation number 2. Here the values of c02, c12 and c22 are unknown. To find these values, we substitute the values of I and n in our equation number A. For finding c01, we substitute I as 0 and n as 2. We derive a function and integrate the function. Put the upper and lower limits and get the value for C02 as 1 by 6. Similarly, we substitute I as 1 and n as 2 in our equation number A to find out C12. We get the function, integrate it, and put the upper and lower limits and get the value for C12 as 4 by 6. As we know that Cin to n is equal to Cin. So here the value of C22 is equal to the value of C02, which is 1 by 6. On putting all these values in our equation number 2, we get equation like this: 2h into 1 by 6 y0 plus 4 by 6 y1 plus 1 by 6 y2. On taking 6 common from all the terms, we get 2h by 6 into y0 plus 4y1 plus y2. For generalizing the equation for the summation of n terms, we get an equation like this: h by 3 into bracket of y0 plus yn plus bracket of 4 into bracket of y1 plus y3 plus y5 up to yn minus 1 terms plus 2 into bracket of y2 plus y4 plus y6 up to yn minus 2 terms. And this is the final formula for the Simpson's 3 by 8 rule. Following this, the second question was to derive Simpson's 3 by 8 rule again by using the Newton-Cotes rule. So here, the Newton-Cotes rule, as you can see, is NH summation of I from 0 to n yi Cin, and Cin is defined as 1 by n integral of 0 to n Liu du, where Liu du is found out using the Lagrange's interpolation method. We substitute n as 3 in our equation number 1 to derive the Simpson's 3 by 8 rule. We get an equation like 3h y0 c03 plus y1 c1 3 plus y2 c2 3 plus y3 c3 3, and name the equation as equation number 2. Here the values of c03, c13, c23 and c33 are unknown. To find these values, we substitute the values of I and n in our equation number A. First of all, we find c03, where we substitute I as 0 and n is 3 in our equation number A. Again, we get a formula and substitute the upper and lower limits after solving the integral, and we get the final value of C03 as 1 by 8. To find C13, we substitute I as 1 and n is 3 in our equation number A. Get a function, integrate it, put the upper and lower limits, and get the final value of C13 as 3 by 8. As we know that Cin 2n is equal to Cin. So here we can say C23 is equal to C13 is equal to 3 by 8, and C33 is equal to C03 is equal to 1 by 8. We substitute all the values in our equation number 2 to derive the final value of I. So we get I1 as 3h bracket of 1 by 8 y0 plus 3 by 8 y1 plus 3 by 8 y2 plus 1 by 8 y3. On taking 8 common, we get the equation like this: 3h by 8 into y0 plus 3y1 plus 3y3 plus y3. On generalizing the equation for summation of n terms, we get an equation like 3h upon 8 into bracket of y0 plus yn plus 3 into y1 plus y2 plus y4 plus y5 up to yn minus 1 and yn minus 2 terms. plus 2 into y3 plus y6 plus y9 up to yn minus 3. This is the final formula for the Simpson's 3 by 8 rule. Following this, the third question was to write an algorithm for Runge-Kutta method. The method is primarily used to find the values of y1, y2, y3 for the given values of x1, x2, x3. Here we have four partial increments in the value of y and the formula for the final partial decrement, which is the final value of our y1. So here we write the algorithm. The first step is reading x1, y1, x of f and h, and we apply a loop for x1 less than equal to xf. We print the values of x1 and y1 and assign the function of x1, y1 to s1. We change the value of x2 by assigning it x1 plus 0.5h and change the value of y2 by assigning y1 plus 0.5h s1 to y2. Again, we define a variable s2 where we assign the function of x2 and y2 and increment the values of y2 by assigning y1 plus 0.5 hs2 to y2. And again, we assign the function of x2 and y2 to our x3. In the third increment for our partial increment, we assign y2 as y1 plus hs3 and x2 as x1 plus h. We assign the function of x2 and y2 to s4. And we assign as s1 plus 2s2 plus 2s3 plus s4. And the final increment is assigned as y1 plus h into s upon 6. Now we assign the values of y2 to y1 and x2 to x1, end of a while loop, and this is the end of the algorithm. The algorithm gives the output as the final value of y1 corresponding to the value of given x1. Following this, the fourth question was to write an algorithm for the linear regression method. So basically in this method, we have a dependent variable and an independent variable. And we find the change in the behavior of the dependent variable as we change the independent variable. So as the algorithm begins, we read the value of n and assign 0 to the sum of x, sum of y, sum of xy, and sum of x square. We run a loop for I is equal to 1 to n and increment I by 1 in each iteration. Simply, we read the values of x and y for all the iterations and assign some x plus x to some x, some y plus y to some y, some xy plus x into y to some xy, and some x square plus x into x to some x square. We end the loop here. And again, we initialize a variable called denominator where we assign n into sum of x square minus some x into some x. And the value of a0 is defined as some y into some x square minus some x into some x divided by the denominator. The value of a1 is assigned as n into some xy minus some x minus some y, which is divided by the value of denominator. We print the values of a0 and a1 and end the algorithm. The algorithm outputs the change in the behavior of the dependent variable as we change the independent variable. These are the solutions for all the questions in the internal third of Onam. That's all from this video.